converging or diverging using the ratio test. So then in order to do that, we first need to find the sequence un, which would be n plus 1 power to 10 over 10 power n plus 1 over n power to 10. And then if we simplify this, equal to so that would be our new sequence un. So now we need to find the limit of this new sequence. Well, let's write out. Any suggestions on how to do this without having to do binomial expansion of n plus 1 power to 10? Well, I have an idea. I don't know.
Could you take the 10 square root of that?
No, it's the same thing.
No, maybe not.
I don't know. But I was thinking because here, the term with n to the power of the highest power will be 1 times n power to 10. So that will be the first term of the binomial expansion. And all of the others will disappear because they have lower powers. Right? So then we will have 1 over this divided by n power to 10, so we just have 1/10. But I don't know if that's valid. That makes sense. So what should I write?
You divide by n.
Right.
Try it out.
So you divide everything by n to the power of 10.
So basically, what we end up doing is when we expand this, we will end up with n power to 10 plus something times n power to 9 plus something times n power to 8 and so on and so forth. But all of the terms, but then if we divide through by 1 over n power 10 in the numerator and
We
denominator.
divide by n to the power of 10.
Yeah. Or we multiply by 1 over n power to 10. So if we do that, then all of the terms, the ones that are n power to 9, n power to 8, n power to 7, etc., as n approaches infinity, those will disappear. And we'll only be left with n to the power of 10 over n to the power of 10, which is 1. So we have 1 divided by 10 n to the power of 10 over n to the power of 10, which is... Does that make any sense?
Yeah.
You said I multiplied everything by 1 over n.
Yeah, we multiply everything. So here, if we were to expand this, and then multiply everything by 1 over n to the power of 10, and then down here as well,
Then we, yeah, then we would.
n to the power of 10. So all of the terms with powers less than 10 would go away. Because as n approaches infinity, they would approach 0, and they would just become insignificant.
N would end up in the denominator. And as n goes to infinity, they would go to 0.
Yeah, so I mean, if we have, n plus 1 squared over n squared, we would have n squared plus 2n plus 1 over n squared. And if we
We would 2n plus 1.
we'd have 1 plus 2 over n squared over 1. And then these terms, as n approaches infinity, would go away. Right? And so we'd be left with 1 over 1 at the limit. And so here the same thing would happen with all of the terms except the one which is n power to 10. Right?
Maybe if you try and expand.
No.
did I just write that?
It makes sense.
No, but it's a good explanation.
And then this is less than 1,
That's right.
which means that according to the ratio test, this